Hello everyone, it's Tutor Fortune here. So we are the equation on intermolecular forces, okay, which is saying a patient requires an IV fluid isotonic with blood. Okay, so we've been given the the osmotic pressure of blood, which is 7.7 atmosphere. Okay, at a temperature of 37 degrees Celsius. Okay, then they are saying two options are available. Okay, so you either have solution 1, which is 0.3 molarity of your glucose. Okay, so the other solution is solution 2, which is 0.15 molarity of your calcium chloride there. Okay, then we've been given an assumption there, assuming that 80% dissociation. So there is 80% dissociation of this calcium chloride. Okay, meaning the Van Hoff factor for this after 80% dissociation is 2.6. Okay, then you have part A there, which is saying calculate the osmolarity or the osmotic pressure. So we have to calculate the osmotic pressure for both solutions. Okay, so let's start with the solution A. Let's calculate the osmotic pressure for solution 1 there. Okay, the first solution. Okay, so you know that the osmotic pressure is given by, okay, osmotic pressure given by, so you get your Van Hoff factor. Okay, multiply it with the, okay, molarity. Okay, then you multiply it with the rate constant R. Also you multiply it with the temperature. Okay, so this is the formula for osmotic pressure. Okay, so let's calculate our osmotic pressure for solution 1 here. Okay, so now what's the Van Hoff factor for solution 1? Okay, so you have your glucose molecule there. So your glucose molecule does not dissociate that. Okay, so this glucose molecule does not dissociate. So it remains with the one, it remains the way it is as one molecule. Okay, so meaning the Van Hoff factor for your glucose molecule, so the I there is going to be 1. Okay, so the I is equal to 1 for your glucose because this guy does not dissociate. Okay, so here, where you have the Van factor, we are going to put a 1 for glucose. Okay, multiply by the molarity of glucose being given, okay, which is the 0.30 molarity there. So I'll say I have my 0.30. So molarity is the same as mole per liter there. Okay, then I have my rate constant. Okay, so the rate constant of use is 0.8. Okay, so 0.08. So I have 0.0821. Okay, liters atmosphere. So liters atmosphere per mole Kelvin, like that. Okay, so this is the rate constant times, okay, the temperature. Okay, so the temperature is at which temperature? At 37 degrees Celsius. Okay, so I have that 37 degrees Celsius. I convert it to Kelvin. I'm going to get about 110.15 Kelvin. So I'm simply adding 273.15 to that 37. Okay, so I'm converting my temperature in degrees Celsius to Kelvin by adding 273.15. Okay, so you get your 310.15. Okay, as your temperature in Kelvin. Okay, so now there I can calculate my osmotic pressure for solution 1. Okay, so I'll get my 1, I multiply by 0.30. Okay, then I multiply with the 0.0821. Then I multiply it with the 310.15 there. Okay, so I'm going to get 7.639 atmospheres. Okay, so that's my osmotic pressure, okay, for solution 1. So the Kelvin and the Kelvin there will go, the more and the more will go, the liter and the liter will go. That's the reason why I'm remaining with these units, the atmospheres. Okay, so for solution 1, I'll write it here. For solution 1, my osmotic pressure pi is equal to 7.639 atmospheres. Okay, so let's keep it. Let's go to our solution 2. Okay, so I'll keep my formula. I'll go to my solution 2. Okay, now I'm dealing with solution 2. Let me find the osmotic pressure for my solution 2. Okay, as asked in part A. Okay, so for solution 2, the bond factor we've been given there is 2.6. Okay, doesn't have unit. Okay, so this one has no units. Okay, then the molarity we've been given there is 0.15 mole per liter. Okay, then osmotic pressure, the rate constant is 0.082. Okay, so 0.0821 liters atmosphere per mole Kelvin. Okay, like that. Okay, those are my units for rate constant. Okay, then the temperature at this same temperature, which is 37 degrees Celsius. Okay, so there the temperature still remains 310.15 Kelvin. Okay, so the same thing, the Kelvin and the Kelvin there will go, molarity, moles and the moles will go, then liters and the liters there will go. So I'm remaining with atmospheres as my unit for my final osmotic pressure there. Okay, so if I multiply my 2.6 by 0.15, again by 0.0821, then I multiply it with 310.15. Okay, so there I'll get my osmotic pressure for the second one, which is 9.931 atmospheres. Okay, atmospheres. Okay, so here I have my osmotic pressure for solution 2, which is 9.93 atmospheres. Okay, then the first one, it was 7.64 atmospheres. So I can write 64 to have uniformity there. You can say I have 7.64 atmospheres. Just round it off to three significant figures, both of them. Okay, so these are my osmotic pressures. Okay, so for solution 1 and solution 2, these are osmotic pressures. Okay, so let's go to part B. So part B is saying which solution is isotonic. Okay, so which solution here is isotonic? Okay, so we've been given the osmotic pressure for blood, which is 7.7 atmosphere. Okay, so having been given the osmotic pressure for blood, we have these two osmotic pressure. So you can see here we have the solution 1 osmotic pressure, which is 7.64, and the solution 2, the osmotic pressure, which is 9.3 atmosphere there. Okay, so you can see in terms of osmotic pressure difference between blood and these two solutions. Solution 1, the osmotic pressure is small. The osmotic pressure difference is very small compared to solution 2. Okay, if you are comparing them with blood. Okay, so here the difference between the osmotic pressure of blood and the osmotic pressure of your solution 1 there should be 0.8%, which is very small. So we can conclude that this solution 1 is isotonic. Okay, so this solution 1 is isotonic. Okay, then we go to part C. So part C is saying in a biochemical lab, you test solution 2, okay? So you get this your solution 2 with this osmotic pressure, okay? So this is your solution 2. Then we have the osmotic pressure there. Then you place your erythrocyte, your red blood cells, okay? So predict and explain the physiological outcome. So what will happen if you place your red blood cell in this solution? So here you've checked, you've seen that the osmotic pressure for solution 2 and that one of blood is different, okay? So the osmotic pressure for solution 2 is greater than that one for blood. So meaning this solution is a hypertonic solution. So what happens when you place a cell in a hypertonic solution? What will happen? Okay, so you find that by osmosis, the water molecule inside this cell, okay, will start moving from the cell out to the ECL. Okay, so it will start coming out the ECL through osmosis. Okay, so you find that this cell will undergo what we call prenation. Okay, the cell will undergo what we call prenation or shrinking. So there will be a cell shrinking. Okay, so that is what is going to happen when you place your red blood cell to this solution. Okay, so now you can watch a full video solution for your tutorial sheets by subscribing with us. So how you subscribe? You simply open the browser. Okay, so let me just show you how you can subscribe with us. Okay, so you open your browser. Okay, when you open your browser, like that, okay. So you open your browser, then you type Discrete Learning Institute, okay. Then you click that website for Discrete Learning Institute, okay. When you click the link there, so you have something like this will appear, okay. So if you don't have an account, you'll be asked to create an account. So when you create an account, you can pay for the course of your choice, okay. So there are different courses. Here are some of the courses which are there, okay. So let's say you want to pay for chemistry, you pay for chemistry. And once you pay for chemistry, you can open that folder for chemistry. You find something like this, okay. So you can enter in the folder written general chemistry there, okay. So you go in that folder, you notice that you have these other folders. So you open the folder you want. So let's say tutorial sheets and assessment, okay. So you want to get solutions for your tutorial sheets and assessment. You can go in that folder, written tutorial sheets and assessment, okay. Then you choose the university, okay. So let's say UNILAS, I'll choose UNILAS there as my university, okay. When I choose UNILAS, I choose my semester. So let's say second semester, I open my second semester folder there, okay. Then do I want a written solution or recorded videos? So I can go in a folder written recorded videos, okay. Then the intake, so you go in July intake, okay. Then you find these folders for your tutorial sheets, okay. So there's tutorial sheet 1, tutorial sheet 2, your tutorial sheet 3, 4, then your tutorial sheet 6 there, okay. So you open the tutorial sheet of your choice, the one you want, okay. So you say tutorial sheet on intermolecular forces, which is tutorial sheet 2. You can open that tutorial sheet. You find all video solution for that tutorial sheet in that folder, okay. So you do well to subscribe with us so that you are prepared for your exam. Okay. Thank you for watching this video.